flight within 2 weeks. On the 23rd of June, the first flight was postponed due to structural reasons. Boeing provided an updated 787 schedule on the 27th of August, 2009, with the first flight planned to occur by the end of 2009 and deliveries to begin at the end of 2010. The company expected to write off $2.5 billion because it considered the first 3 Dreamliners built unsellable and suitable only for flight tests. On the 28th of October, 2009, Boeing selected Charleston, SC as the site for a second 787 production line, after soliciting bids from multiple states. On the 12th of December, 2009, the first 787 completed high-speed taxi tests, the last major step before flight. Flight testing, edit. The first 787 taking off on its maiden flight in December 2009. On the 15th of December 2009, Boeing conducted the 787-8 maiden flight from Payne Field in Everett, Washington, at 10:27 a.m. PST and landed 3 hours later at 1:33 p.m. at Seattle's Boeing Field. During the flight, the 787 reached a top speed of 180 km, 333 km per hour, and maximum altitude of 13,200 feet, 4,000 m. Originally scheduled for 5 plus 1 /2 hours. The test flight was shortened to 3 hours due to unfavorable weather conditions. The 6-aircraft ground and flight test program was scheduled to be done in 8.5 months and 6,800 hours, which was the fastest certification campaign for a new Boeing commercial design. The flight test program comprised 6 aircraft, ZA001 through ZA006. 4 with Rolls-Royce Trent 1000 engines and 2 with GE GEnx 1B64 engines. The second 787, ZA002 in all Nippon Airways livery, flew to Boeing Field on the 22nd of December, 2009, to join the flight test program. The third 787, ZA004 made its first flight on the 24th of February, 2010, followed by ZA003 on the 14th of March, 2010. On the 24th of March, 2010, flutter and ground effects testing was completed, clearing the aircraft to fly its entire flight envelope. On the 28th of March, 2010, the 787 completed the ultimate wing load test, which requires that the wings of a fully assembled aircraft be loaded to 150% of the design limit load and held for 3 seconds. The wings were flexed approximately 25 feet, 7.6 m, upward during the test. Unlike past aircraft, the wings were not tested to failure. On April the 7th, data showed the test had been a success. On the 23rd of April, 2010, the newest 787, ZA003, arrived at the McKinley Climatic Laboratory hangar at Eglin Air Force Base, Florida, for extreme weather testing in temperatures ranging from 115 to 45 degrees F. 46 to 43 degrees C, including takeoff preparations at both temperature extremes. ZA005, the fifth 787 and the first with GEnx engines, began ground engine tests in May 2010, and made its first flight on the 16th of June 2010. In June 2010, gaps were discovered in the horizontal stabilizers of test aircraft due to improperly installed shims. All aircraft were inspected and repaired. That same month, a 787 experienced its first in-flight lightning strike, Inspections found no damage. As composites can have as little as 1/1,000 th, the electrical conductivity of aluminum, conductive material is added to alleviate potential risks and to meet FAA requirements. The FAA also planned requirement changes to help the 787 show compliance. In December 2019, it was reported that Boeing had removed the copper foil that formed part of the protection against lightning strikes to the wings of the aircraft. It then worked with the FAA to override concerns raised. The 787 made its first appearance at an international air show at the Farnborough Air Show, United Kingdom, on the 18th of July 2010. On the 2nd of August 2010, a Trent 1000 engine suffered a blowout at Rolls-Royce test facility during ground testing. This engine failure caused a revaluation of the timeline for installing Trent 1000 engines. On the 27th of August 2010, Boeing stated that the first delivery to launch customer Anna would be delayed until early 2011. That same month, Boeing faced compensation claims from airlines owing to ongoing delivery delays. In September 2010, it was reported that 2 additional 787s might join the test fleet for a total of 8 flight test aircraft. On the 10th of September 2010, a partial engine surge occurred in a Trent engine on ZA001 at Roswell. On the 4th of October 2010, the 6th 787, ZA006 joined the test program with its first flight. On the 9th of November 2010, the 2nd 787, ZA002 made an emergency landing at Lerdo International Airport, Texas, after smoke and flames were detected in the main cabin during a test flight. The electrical fire caused some systems to fail before landing. Following this incident, Boeing suspended flight testing on the 10th of November 2010. Ground testing continued. After investigation, the in-flight fire was primarily attributed to foreign object debris, FOD, that was present in the electrical bay. After electrical system and software changes, the 787 resumed flight testing on the 23rd of December 2010. Test evaluation and certification, edit. On the 5th of November 2010, it was reported that some 787 deliveries would be delayed to address problems found during flight testing. In January 2011, the first 787 delivery was rescheduled to the third quarter of 2011 due to software and electrical updates following the in-flight fire. By the 24th of February 2011, the 787 had completed 80% of the test conditions for the Rolls-Royce Trent 1000 engine and 60% of the conditions for the General Electric GX-1B engine. In July 2011, ANA performed a week of operations testing using a 787 in Japan. The test aircraft had flown 4,828 hours in 1,707 flights combined by the 15th of August 2011. During testing, the 787 visited 14 countries in Asia, Europe, North America, and South America to test in extreme climates and conditions and for route testing. On the 13th of August 2011, certification testing of the Rolls-Royce powered 787-8 finished. The FAA and European Aviation Safety Agency certified the 787 on the 26th of August 2011, at a ceremony in Everett, Washington. Entry into service, edit. All Nippon Airways flew the first commercial 787 flight on the 26th of October, 2011. Certification cleared the way for deliveries, and in 2011, Boeing prepared to increase 787 production rates from 2 to 10 aircraft per month at assembly lines in Everett and Charleston over 2 years. Legal difficulties clouded production at Charleston. On the 20th of April, 2011, the National Labor Relations Board alleged that a second production line in South Carolina violated 2 sections of the National Labor Relations Act. In December 2011, the National Labor Relations Board dropped its lawsuit after the Machinists Union withdrew its complaint as part of a new contract with Boeing. The first 787 assembled in South Carolina was rolled out on the 27th of April, 2012. The first 787 was officially delivered to All Nippon Airways, ANA, on the 25th of September, 2011, at the Boeing Everett factory. A ceremony to mark the occasion was also held the next day. On the 27th of September, it flew to Tokyo Haneda Airport. The airline took delivery of the second 787 on the 13th of October, 2011. On the 26th of October, 2011, an ANA 787 flew the first commercial flight from Tokyo's Narita International Airport to Hong Kong International Airport. The Dreamliner entered service some 3 years later than originally planned. Tickets for the flight were sold in an online auction. The highest bidder had paid $34,000 for a seat. An ANA 787 flew its first long-haul flight to Europe on the 21st of January, 2012, from Haneda to Frankfurt Airport. Proposed variants, edit. Freighter version, edit. Even after production of the 787 began, Boeing continued to produce the 767 as a freighter. More stringent emissions and noise limits will go into effect in 2028 and prevent 767 sales in its current form. To address this concern, Boeing has widely reported to be working on a freighter version of the 787, showing proposals to customers including FedEx Express. As of May 2024, production of the 787 freighter is expected to begin between 2028 and 2033. 787-3, edit. The 787-3 would feature a reduced wingspan with wingtip devices. The 787-3 would have carried 293-30 passengers in 2 class over 2,503,050 mi, 4,635,650 km, 2,883,510 mi, range, limited by a 364,000 pound, 165 t, tow. In April 2008, to keep the 8 on track for delivery, the 9 stretch was postponed from 2010 to at least 2012 and prioritized before the 787-3 and its 43 orders to follow without a firm delivery date. It kept the 8 length, but its 51.7 m wingspan would have fit in ICAO Aerodrome Reference Code D. It was designed to operate on Boeing 757-300 /Boeing 767-200 sized regional routes from airports with restricted gate spacing. The wingspan was decreased by using blended winglets instead of raked wingtips. By January 2010, all orders, from Japan Airlines and All Nippon Airways, had been converted to the 787-8. As it was designed specifically for the Japanese market, Boeing would likely scrap it after they switched orders. The 8's longer wingspan makes it more efficient on stages longer than 200 mi, 370 kilometers, 230 mi. In December 2010, Boeing withdrew the short-haul model as it struggled to produce the 787-8 after program delays of 3 years. Market and costs, edit. The 787 Dreamliner program has reportedly cost Boeing $32 billion. In 2013, the 787 program was expected to be profitable after 1,100 aircraft have been sold. At the end of 2013, the cost of producing a 787 exceeded the purchase price. Boeing's accounting method books sales immediately and distributes estimated production costs over 10 years for the 1,300 aircraft it expects to deliver during that time. J.P. Morgan Chase analyst Joseph Nadol estimated the program's cash loss to be $45 million per airplane, decreasing as the program moves forward. The actual cash flow reflects Boeing collecting most of the purchase price upon delivery. Boeing expects deferred costs to total $25 billion before the company begins to break even on production. The comparable number for the Boeing 777, adjusted for inflation, is $3.7 billion. Boeing lost $30 million per 787 delivered in the first quarter of 2015, although Boeing planned to break even by the end of the year. The accumulated losses for the 787 totaled almost $27 billion, $33.9 billion in 2023, by May 2015. The cost of producing the fuselage may increase because of a tentative deal reached with Spirit AeroSystems of Wichita, Kansas, wherein severe price cuts demanded by Boeing would be eased, in return for a comprehensive agreement that lowers the cost of fuselages for other jetliners that Spirit helps Boeing manufacture. In the second quarter of 2015, Boeing lost $25 million. $31.4 million in 2023, on each 787 delivered but was planning to break even per plane before the year end. After that, Boeing hoped to build 900 Dreamliners over 6 years at an average profit of more than $35 million each. But with deferred costs peaking in 2016 at $33 billion, $41.1 billion in 2023, Leham analyst John Furham believes Boeing cannot make an overall profit on the program. Ted Pipenbrock, an academic affiliated with MIT and the University of Oxford, projects losses decreasing through the first 700 airliners and forecasts the cumulative deferred costs to peak beyond $34 billion. The model most favorable to Boeing projects a program loss of $5 billion after delivering 2,000 Dreamliners. Boeing's original development investment, estimated at least at a further $20 billion, is not included in these costs. To recoup the deferred costs and earn its goal of a low single-digit overall profit margin, Boeing has to make an average profit of more than $50 million on the final 205 airplanes of the accounting block to be delivered from 2020, a profit margin of more than 30%, while the mature Boeing 737 and 777 programs have 20% to 25% margins. Boeing is reaching it through a larger proportion of the 20% to 40% higher price 9/10s, costing only 5% to 10% more than the 8 with lower production costs from reliability and producibility investments and the expected experience curve. Former Douglas Aircraft chief economist Adam Pilasky notes that 2 assembly sites slow the experience curve. Boeing assumed a faster improvement than on previous programs, which had not happened. Competition with the Airbus A350 and the launch of the A330neo put strong pressure on the 787 pricing. On the 21st of July, 2016, Boeing reported charges of $847 million against two flight test 787s built in 2009. Boeing had planned to refurbish and sell them but instead wrote them off as research and development expense. In 2017, Boeing's Jim Albaugh said that the requested return on net assets, RONA, led to outsourcing systems reducing investment, but improving RONA had to be balanced against the risk of loss of control. From 2019, Boeing was to build 14 787s per month, 168 per year, helping to offset the $28 billion in deferred production costs accumulated through 2015 and would add 100 aircraft to the current accounting block of 1,300 at the end of 2017 third quarter. In 2019, the list price for a 787-8 was $248.3 million. $292.5 million for a 787-9, and $338.4 million for a 787-10. The valuation for a new 787-9 is $145 million in 2018, up from $135 million in 2014. But it may have been sold for $110,115 million to prevent a 330neo sales, while an A330-900 is worth $115 million. In February 2018, Boeing priced 6 787-9s for less than $101.15 each to Hawaiian Airlines, close to their production cost of $80.90 to overcome its A330-800 order. By late 2018, deferred production costs were reduced from a peak of $27.6 billion in early 2016 to $23.5 billion as assembly efficiency improved and the 800th production started. Production rate, edit. By 2014, Boeing planned to improve financial return by reorganizing the production line, renegotiating contracts with suppliers and labor unions, and increasing the 787 production rate, stepwise, to 12 airplanes per month by the end of 2016 and 14 airplanes per month by the end of the decade. By April 2015, the production rate was 10 per month. From late 2020, the production rate is to be reduced from 14 to 12 airplanes per month due to the China-United States trade war. Production could be trimmed to 10 planes per month as demand for wide-body aircraft falters. On the 1st of October 2020, Boeing announced the 787 would be produced only in North Charleston from mid-2021 due to the impact of the COVID-19 pandemic on aviation, as the production rate fell to 6 per month. In December, the monthly rate was further reduced to 5. Quality control issues, 2019-2024, edit. 2019, edit. In 2019, reports began to emerge about quality control issues at the North Charleston plant, leading to questions about the jet's safety, and later that same year KLM, which had discovered loose seats, missing and incorrectly installed pins, nuts and bolts not fully tightened and a fuel line clamp left unsecured on its jet, complained that the standard of manufacture was way below acceptable standards. 2020, edit. Early in 2020, Boeing engineers complained about depressions in the 787's vertical tail fin, affecting hundreds of planes or the vast majority of the fleet. Workers in Charleston and Everett had improperly discarded shims before the final installation of fasteners, which could lead to structural failure under limited loads. In late August 2020, Boeing grounded 8 787s due to such improper fuselage shimming and inner skin surfacing issues which proved to have been discovered in August 2019 at Boeing, South Carolina. The following month, Boeing admitted that non-conforming sections of the rear fuselage did not meet engineering standards, and the FAA was investigating quality control lapses dating back to the introduction of the 787 in 2011 and considering requiring additional inspections for up to 900 of the roughly 1,000 Dreamliners in service. The FAA then began to inquire into the company's quality management system, QMS, which Boeing had previously argued justified a reduction of 900 quality inspectors, but which had failed to detect either the shim or skin surface issues. A third quality control issue then emerged, this time with the 787's horizontal stabilizers, and affecting as many as 893 Dreamliners. Workers in Salt Lake City had clamped portions of the tail section too tightly, which could lead to premature material fatigue. At this point, Boeing expected a one-time inspection during regularly scheduled maintenance to address the issues and expected merely to slow 787 deliveries in the near term. 2021, edit. By January 2021, Boeing had halted 787 deliveries to complete the inspection relating to poor quality control. Then in March the FAA withdrew Boeing's delegated authority to inspect and sign off on 4 new 787s, saying that it would extend this withdrawal to further aircraft if needed. Boeing briefly resumed deliveries on the 26th of March, 2021, handing over one 787-9 to United Airlines. But deliveries ceased again in May 2021, meaning that almost all deliveries had been paused for nearly a year. The delay generated $1 billion in abnormal costs and caused the company to cut production to around 2 planes a month. On the 13th of July, Boeing discovered gaps at joints in the forward pressure bulkhead and again reduced production. The company also investigated whether the issue affected 787s already in service. Questions were asked about the inspection process used to check the work, and Boeing worked with the FAA to fix the problem, which was said to pose no immediate threat to flight safety and did not require 787s already in service to be grounded. On September the 4th, the Wall Street Journal reported that the FAA would not accept Boeing's proposed new inspection method, aiming to speed deliveries with targeted checks rather than nose-to-tail teardowns, until at least late October, and in late November it was reported that the FAA had discovered further problems, including additional out-of-tolerance gaps and contamination and associated weakening of fuselage composites. The rectification process for existing aircraft was made more complex by a lack of detailed configuration data on each aircraft. The new problems and the extension of the 13-month-long disruption to 787 deliveries led to anger from buyers, a slide in the company's stock price, and demands by a subcommittee of the U.S. House of Representatives for a review of the FAA's oversight of the plane. 2022, edit. In January 2022, it was reported that deliveries were not anticipated to restart until April 2022. In February, the FAA announced that it would withdraw Boeing's delegated authority to issue airworthiness certificates for individual 787 aircraft until Boeing can demonstrate consistent quality, stable delivery processes, and a robust plan for the rework needed on the undelivered aircraft in storage. In late March, Boeing began sounding out suppliers about their ability to support the production of up to 7 aircraft a month by late 2023. Vistara, which had been expecting delivery of 4 Dreamliners in 2022, indicated a lack of confidence in Boeing meeting its delivery aims by arranging to lease aircraft instead. Later in April, reports began to emerge of a further delay of at least 2 months, and it was only in late April that Boeing submitted the necessary certification package laying out the inspections and repairs to be undertaken on already constructed planes. The FAA rejected portions of the package as incomplete and returned it to Boeing, indicating a further delay before the resumption of deliveries. In late July, the FAA approved Boeing's revised certification package, leading the company to anticipate resuming deliveries within days. Deliveries resumed on the 10th of August, 2022, after the FAA granted clearance.